Okay, this is number 5 from the curve setting worksheet. And just going to run through setting up the equation real quick. So since the maximum's at 120 and the minimum's at 104, the difference is 16. So we cut that in half, and that's 8. That's where that came from. The amplitude is 8. And if you add 8 to 104 or subtract 8 from 120, you get 112. So that's the vertical shift, or the midpoint. And it takes 20 minutes to go from the maximum right there to the minimum. So that would be half of a period. So that means the total period is 40. So that means the frequency would be 2 pi over 40. So that's where the pi over 20 comes from. And then finally, I put a cosine in and put x minus 35 because I figured I just shifted ahead to that maximum. Now you could have shifted backwards to this one. I think that would have been plus 5. Either way is fine. Both equations will work. If you wanted to use sine, you'd have to shift it ahead. You'd have to shift ahead the middle to there, which would be a little bit harder to figure out what that is. So I think it's easier just to use cosine. Okay, so now once you get that, this is maybe the harder part, is the questions. What was its temperature when they first started timing? So the temperature when we first started timing just means that the time is 0. So that you would just plug in 0 for x. So that would leave me with negative 35 pi over 20 plus 112. And if I enter that into my calculator, so when I plug that into my calculator, I get 117.7 degrees. So, and then we just go back to make sure that makes sense. If we go back here and look at it, it is on getting close to the top. So 117 sounds like a reasonable answer. It should be higher than halfway. The midpoint should be higher than 112. So that seems like that's a pretty reasonable answer. Okay, so then part D says find the first 3 times after they started timing at which the temperature is 120 degrees. Now, 120 degrees is the high point. So we know the first time is at 35 degrees. So we can easily say that. 35 minutes. So 35 minutes would be the first time. And we know that because its period is 40, that means it's coming every 40 minutes. So if we add 40 to 35, that'd be 75. And then if we add 40 again, that would be 115. All those are minutes. Now, let's say they wouldn't have said, let's say instead of 120 degrees, they would have said 110. Then we'd have to replace y with 110 and solve for x and find out where it is on the graph, and then do some fancy adding to get to the other things. So I'm going to do that just because I think that's a harder problem. So if we do 110 is equal to, let me make some room here. 110 is equal to 8 cosine of pi over 20 times x minus 35 plus 112. So if I subtract 112 from both sides, I get negative 2. Divide that by 8, I get negative 1/4, which would be 0.25. And then I'm ready to take the inverse cosine of both sides. So I'll take second cosine of negative 0.25, and that gives me 1.8235. Of course, that's equal to pi over 20 times x minus 35. So then I would multiply that by 20 and divide that by pi. That gives me 11.6, and then I would add 35 to it. So I end up with x is approximately equal to 46.6. So that would be one of, and that's of course 46.6 minutes. That would be one of the times that the temperature is 110. So now let's go back up and look at our drawing. What did I say? 46? 46.6. So 46.6 would be in here somewhere. A little bit below the midpoint, so it'd be maybe right about there. I need to grab a different color. So we can tell just by looking at the graph that there's got to be another one over here somewhere, and then the next one's going to be on beyond that. And if we're looking for 3 of them, that the first 3 times after the beginning of timing, that hits 110, the question, these 2 are obviously 2 of them, but the question is, the third one going to be over here or is it going to be right there? Will it fit in? You know, I think because we're looking at 110, which would be below the halfway mark, it would probably be down there somewhere. So I think our first 3 are going to be there, there, and there. So the one that we just found is right here. We know that this is 46.6. Now, how do we find the other one? Well, because of the symmetry of cosine, we know that this distance here should be the same as that distance there. Because that's the same y value, they should be the same distance on either side of the maximum. So since this is, let's see, 46.6 minus 35, so that distance is 11.6. That means this would also have to be 11.6. And so we're going to take 35 and subtract 11.6. So that would give me 23.4. And then I also know that this point right here would be 11.6 from that maximum. So I could just take, and we know that maximum is -5, so we go -5 plus 11.6. And that would give me, this guy right here would be 6.6. So that would be my 3 answers. 6.6, 23.4, and 46.6. And remember, we got the 46.6 by solving this equation to get one of them, and then we just use symmetry to find the other 2. All right, hopefully that's helpful.